Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Dimensional Analysis by Fenners. And here are the rules. We have normal 9 by 9 Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have an extra region construction, or like another equivalent is this is basically like chaos construction, but on top of a normal Sudoku grid. So basically, there are nine cell orthogonally connected extra regions in the grid that you must construct, where each digit from 1 through 9 must appear in each extra region. And so basically, it is basically like chaos construction, but except that we also have the additional Sudoku limitations involved, where with the 9 3x3 boxes, or designated 9-cell regions, essentially. But we also have 9 regions that we have to construct, and every cell must be part of one of these extra regions, right? So this is a valid constructed region because it's orthogonally connected to itself. And that means that you can connect, you can basically connect from any cell in that region and go to any other cell in that region and still stay within that region just by going through edges. So this is a valid orthogonally connected region. This, however, is not, because if you tried to go from any cell here to that cell, you can't stay within the region just by going through edges, right? If you try to go through edges, you would have to go outside the region to go to somewhere else. Same with this. This is not a valid orthogonally connected region, because if you try to go from any of these spaces to these spaces, you can't stay within the region just by going through edges. Even though these two can connect to each other, they cannot connect to any other part of the region. And that's the reason why I explain it that way. So that's how extra region construction works. Basically, think of it as a chaos construction rule set, but on top of a normal Sudoku grid. We also have arrows, where digits on a tail of an arrow must sum to the digit in the bulb. And the tail of an arrow is in the same extra region across its length, but in a different region to its bulb. And the digit in the bulb indicates how many cells of its extra region are in its 3x3 box. Okay, so let's take this into detail. Let's break it down. The digits on a tail of an arrow must sum to the digit in the bulb. So this is typical arrow construction or arrow rule set. So for example, you could have something like 3 and 4, and this is 7, because the digits along the arrow must sum to the digit in the bulb. The tail of the arrow is in the same extra region across its length. So these have to be in the same region as each other. But they have to be in a different region than the bulb, because that's the rule set here. So these have to be one region, this has to be a separate region here, right? But these have to be the same as each other, and they have to be different than the bulb. And the digit in the bulb indicates how many cells of its extra region are in its 3x3 box. So for example, if this were, say, a 5, then the digits in this the number of cells that are in this extra region that are in this specific region have to be 5, right? You can't have 6, you can't have 4, or any more than that, or any less than that. It has to be exactly 5. So these have to be other regions. But it cannot be the same region as the one with the circle, or the digit in the bulb, essentially. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So this is different than these two. Okay, let's mark the borders. I like marking borders here. Ooh, that's not good. Let's just go all the way around. And then we have to have a different boundary there. We have to have a different boundary there. The diagonal ones are going to be a little difficult, though. Anyways. These all cannot be the same region, right? Because if they were the same region, they would have the same amount of, they would have the same digit in these boxes, right? Same with these two. Same with those two there. So we're going to make this one light, and we're going to make this medium gray. This light has to be with one of these, right? And these, actually, all of these digits must add up to 9 at most. So this is at least 9. Or sorry, at most 9 between these three regions, because there's only 9 possible digits in the, or 9 possible cells in the box. And since these detail how many cells are in their extra region, it has to be add up to at most 9. So this is at least the sum of 2 unique digits. So this is at least 3. This is at least 3. Well, there you have it. And you have 3 digits which must add up to at most 9. Anytime you have 3 digits that add up to at most 9, one of them, you have to have 2 digits from 1 through 3. So 3 has to be one of these 2 digits. And then this must be 1 or 2. Right? And the reason why you know this is that basically, well, what do we have? You have 3 digits, 3 unique digits, which add up to 9 or less. The only possible combinations are 1, 2, 3 adding up to 6, 1, 2, 4 adding up to 7, 1, 2, 5, and 1, 3, 4 adding up to 8, 1, 2, 6, 1, 3, 5, or 2, 3, 4 adding up to 9. Notice in all those sets, all of them contain 2 digits from 1, 2, and 3, right? At least. 6 obviously contains all 3, but that's not possible. So 7 contains 1, 2, and 4, but it contains 2 digits from 1, 2, and 3. 8, 1, 2, 5, and 1, 3, 4 contain 1, 2, and 1, 3 respectively. And for the 9s, you have 1, 2, 6, which contains 1, 2, 1, 3, 5, which contains 1, 3, and 2, 3, 4, which contains 2, 3. So we know, since these have to be the sum of 2 unique digits, it's at least 3. We know one of these is 3. If one of these is 3, so say this was a 3 here, this would force this to be 1, 2, and 1, 2. Actually, let's make this one 3. If this is 3, this is 1, 2, 1, 2. That eliminates 1 and 2 in the rest of this row, and this 1, 2, 1, 2 pair eliminates 1, 2 in the rest of this column. So this is at minimum 3 and 4 adding up together. And therefore, this would be 7. But that 7 is never allowed in 3 digits adding up to... so we know, first of all, this can't be 6, because we know there has to be a 3 involved. So this is either 3 with 4 or 3 with 5. The thing is, if you have 3 here, this forces this to be 1, 2 pair. That eliminates 1 and 2 here. This 1, 2 pair here, because this has to be 1 or 2 to add up with 3 to add up to at most 9. This 1, 2 pair and this 1, 2 pair eliminates 1, 2 here. So this is at least a minimum of 3 and 4 then, which would have to be 7. And 7 with 3 and 1 adds up to already greater than 9. So this can never be the 3. Therefore, this has to be the 3. And we know this must add up to 1 and 2. Sorry, this has to be a 1, 2 pair to add up to 3. Well, this 1, 2, 1, 2 pair eliminates 1 and 2 here. So this is at most 3. It could be 3 or 4. And this has to be 1 or 2 to add up to these digits. If this is 3 and 1, this would then be 4, 2, and 2. So this region cannot be the same as this one, because if it were the same, this would be already 3 cells. So this has to be a different region. If this is 4, this is 3 and 1, which would make this 2. And this would have to be the same. So that would be 2. And this would be 1. And this would be 2. So again, if this is 4, this is 3 and 1. This is 2. This is 2. So this adds up to 9. If this is 5, obviously this is 1 and this is 1. So this being 1 forces this to be 2, and this has to be 3. So either way, this is 3. So this is 3, and then this would be 5 and 1. Well, can this ever be part of this region? To connect with it, it cannot. So it would have to basically connect this way, right? So this actually has to go like that. And therefore, this has to be 5. Because otherwise, there's no other way to connect with the circle. And these always add up to 9. So this is part of one of these regions here. So because of that, it cannot be part of the 3 because it would be greater than 3 in size. It can't be part of this because this would be at least 3 in size. So it must be part of this one, which forces this to be a 5. This must then be 1. So this is 1. This is 3 and 2. So this 2 eliminates 2 here. So that's 1. This is 2. So this is a separate region here. This has to be a separate region then, because you need 3 digits in that region. And this is a separate region here. And it has to be different from here. It has to exit out this way. It doesn't necessarily have to be medium, so we're going to make it pink for now. But we don't know. This is green. It must extend out somewhere. This digit is at least, okay, so this is at least 2 and 4 adding up. So it's 2 and 4. It could be 2 and 6. It cannot be 4 with anything. So the 2 has to be on this arrow because we already have 1, 3, 5 accounted for. So 2 could be with 4, 2 could be with 6. It cannot have, so this cannot add up to 9 because this is a different region than this. And so therefore these are 2 different regions here. So it can never contain all of these. So this is 2 with 4 or 6. And 2 cannot be here because of this 2. Therefore, this is a 2 here. Let's see. So this is 6 or 8. If this is a separate region than the gray, then this has to go at least 3, and therefore this would never be 6 or 8. So this has to be the same as the medium gray region. We have 6 or 8. This is a separate region. We don't know which region that is. This is 4 or 6. These are different regions than each other. 2 is here. So this cannot be 2. It cannot be 1. This is at least 3. It can be up to 8 because we have 8 other digits possible in the region to be part of the same region. This is 4 or 6. This cannot be 1, 2, or 3. So this also has to be 4 through 9 possible. But this can't be 5, so this can't be 5 here. These are part of the same region. These are part of the same region. So these are part of different regions here. Okay, so this is light. It cannot go down here. because if it tries to go down here, it would be part of the 2, this region that contains a 2. So this is a separate region here. It cannot be part of green, so it's part of a separate region here. So this has to be light here. These have to be different regions here. So we're going to make this pink, and I guess this will be red. So these have to be different regions because of the 2s in on the arrows. These connect this way. The green has to continue down here. So this is green then. It cannot be 3. And we know it's at least 3 here. So this is 4 or 5. And this is 4 or 5 here. So it has to connect this way. Can it ever go around and avoid this cell? I don't think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So it has to go at least this way. So this is green. So this is a border here. This is a different region here. So this must be light here. And since this is light, that means this medium gray region cannot have 8 digits there. So this must be 6, which makes this 4. This can't be 4, 6. This can't be 4, 6. This must have 7, 8, or 9 here. So this is 1, 2, 3, 4, 5, 6, 7. It could go this way, potentially. This can never be 9. If it were 9, that means all of these would be pink, but then we'd have 10 cells in the pink region. So this cannot be 9. It's either 7 or 8 here. That means this red cannot go in this region, because if this red were to continue here, then it would be part of this region, and we'd have 3 digits here and 7 digits here, which makes a 10-digit region, which is not allowed. So this must go down this way, and it's part of a different region. Therefore, this green region here has 4 digits in that 3x3 block. So this is 4, and it cannot go this way. So it must go this way, and we know it extends all the way there, because it has to have 9 cells. 1 cannot be here, 1 cannot be here, because of the 1s in the boxes. So 1 has to be here in this green region. This is 7 or 8. I guess it could necessarily go something like that. That's possible. 3 cannot be... Well, okay, 3 is here. So this is 4. The rest of column 3 has to be 6, 7, 8, 9. These digits have to be 2, 4, 6, 7, 8. Cannot be 8, because if this is 8, this doesn't have... This cell has nowhere to go, right? And these have to be different regions. And they can add up to at most 9, so neither of these can be 8. This one can't be 7 because 7 plus 3 would add up to 10. So this is 2, 4, and 6. It can't be 6 because of the 6 in the box. So this is 2 or 4. This can be 3, 4, 5, or 7. Because these can add up to 9 at most. Okay, so this is 7 or 8. This is 7 or 8. This is 4. This green also needs a 2, and 2 cannot be here or here because of the 2s in the boxes. So this is a 1-2 pair here. That eliminates 1 and 2 in the rest of that region. So this is 5 through 9. This is 5 through 9, but 5 cannot be here. So this is 5. This is also 5 through 9. This has to be 6 through 9 here, and 6 cannot be here because of the 6 there. This can't be 4 because of the 4 in the row. This cannot be 1, 2, 3, 4, or 5. It can't be 6, so this is 7, 8, and 9. So this is 1, 2, 3, 4, 5, 6, 7. If it tries to go down, 8, it... Okay. One thing is this light region cannot block off this, because then this medium gray region would not have 9 digits. So it cannot go to here. Where can it get the 3? It can't go down here, because then this would have to be part of the same region. Can't go here, and because there would still not be an opportunity for 3. Can't go here for the same reason, because 3s are there. Therefore, this light must go this way to get a 3. And the 3 has to be here, which means this cannot be 3. This gray region must go this way. So it has to go to there. And this is 3, right? That's the 3 digits that it requires. So this has to be the last part of the light region, right? So because these has to be both gray. And this medium gray region is not part of this region at all. So this is light. This is a boundary then here, because these are different regions necessarily. We have 1, 2, 3, 4, 5, 6, 7. This medium gray region does not have a 3, but it could go here or it could go down here. So this can never be 8 as a region. So this actually could be 8. As long as this is pink. This has to be pink then. So this is pink, which means it must be part of this region too, because if it doesn't, it would not have 7 or 8 cells in that region in the middle box. So it has to be part of this. This is still 7 or 8. This has to be 6 through 9. Oops. 6 through 9 here. These are 4 through 9. This is necessarily a different region than this, so it cannot be 8 or 9. So these two are different regions than that one. This cannot be 3, it cannot be 4. So this is at least 5 here. This must be at least 1, 4 to 1, 7, 8, right? That's a possibility. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the light gray is all taken into account. The green is all taken into account. This at least adds up to 7. This is 1, 2, 3, 4, 5, 6, 7. It could be just 2 digits here. That's possible. This region, though, already has all of 2 and 4, right? Because in the rest of box 2, where are the 2 and 4? It has to be in the medium gray region. So this medium gray region has 2... This is specifically not 1, 2, 3, 4, 6. This is 5, 7, 8, 9. This could be 2, 4, 5, 7, 8, 9. 2, 4, 5, 7, 8, 9. But this can't be 2. So 2 has to be one of these 2 digits here, which means 2 has to be one of those 2 digits there. This has to be 5 through 9 because it's whichever digit it's not here in the green region. That's in column 1. This could be 8 or it's 7. Either way, I think this has to be part of the region, right? If it's not part of the region here, How does it get 7 then? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It can't go around, and it would block that off anyways. So this is always pink. It's either 7 or 8, so it could be at most 1 any other space. These are two separate regions. One of them is at most 7. So 2 has to be one of these two. We don't know which. Oh, this can't be 5. Hmm. This has 5 through 9 in the same region. Can it ever be 9? I don't think so, right? If this were 9, that means this is all the same region. And this red region would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 2 extra digits. So this can never be 9, which means this can't be 8 added up to 1 to add up to 9. It could be something like 8, possibly. 1, 2, 3, 4, 5, 6, 7, 8. Hold up. 1, 2, 3, 4, 5, 6, 7, 8, 9. The problem is you always need 2 digits at least here. 2 cells at least to add up with these other digits. 3 has to be one of these two. So even if this is adding up here, the problem is you can't get 8 here, right? Because that would then block off this region from being a full region. And this has to be at least go this way a little bit. I mean, technically, it doesn't have to. It could go like something like that. I guess like that. But then this would never be 8. So this can't be 8 either, which means this can't be 7 added up with 1. So this is 5, 6, or 7. It could be 7, though, because you could have 9 here, and then this be 7, right? With these two. So that's possible. 6 has to be one of these digits here, so this cannot be 6, which means this can't be 6 here. 6 has to be one of these digits. 9 has to be one of these digits, so this can't be 9 either, so this can't be 9 here. This is 3, 5, 7, or 8 as possibilities. Okay, what else do we have here? This is 2. Interesting. This pink region cannot contain another 3. And if it were to have 8, this can't be 3. Therefore, there would be another 3 in this pink region. So this can't be 8. This has to be 7, which makes this 7. This can't be 7. So none of these could be 7 either because of the 7 in the box. This 6, 8, 9 triplet eliminates 6, 8, 9 in the rest of that box. So this becomes a 3, 5, 7 triplet. This can't be 5 or 7. Sorry, this can't be 7 because of the 7 here. So this is 5, which makes this a 5. This can't be 5 here. That eliminates 7, 3, 7 in the rest of the column. This can't be 7. This can't be 5 because of the 5 in the rest of this box. So 7 has to be one of these two. We're not sure which. This is a 3, 7 pair. This is only 7. So there has to be a 3. So one of these must be a 3 here. Because this can't be 3. So since this can't be 3, it must be part of the pink. And therefore this medium gray cannot connect this way. So it has to go this way to get the full 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the full region here. That means these two are not part of this region. It can never be part of the region because this is not part. This is be a different region than this. This is a different region than this. This must add up to 7. So this is 2 and 5. This is 2 and 5 then. This can't be 2 here. These can't be 5. And this can't be 5 here. So this is a full region. These have to be separate regions here. So this is only 2 digits. Well, it has to be those 2 digits, right? It cannot be part of pink. So we're going to make this, I guess we're going to make this dark, and this will make orange. So dark has to go all the way here to get 5. 2 has to go just to there. Oops. This doesn't close off there. This extends that way. We don't... Okay, so this either goes that way. How would that work? So if it went this way, this is 5 digit cells, 6, 7, 8. It has to close off 9, and this orange region would not be a full 9. So this dark cannot go that way. Dark has to go this way. It has to be part of the same region here. 1, 2, 3, 4, 5, 6, 7, 8. We need another one. So one of these is a 9. We're not sure which. This could be part of orange. This could be part of some blue cell going that way. So we're going to have... this can never be 5 then. This is always at least 4 darks here. So this can never be 6 or 7. It's 4 or 5 here. It cannot be part of pink. It could be, well, no, it can't be part of some other weird region, right? Because that would then block off this orange region. So it has to be part of orange. This is orange then. It can be 5 at least. 2 has to be here and here. 3 cannot be here. 3 has to be one of these digits. 2 has to be one of these 2. So this is 7 digits here. Could be 1 here. This orange needs to go out somewhere. And again, it cannot be part of the pink. So it has to go out this way. So 1, 2, 3, 4, 5, 6. It could go here. We don't know. This dark finishes here. So this is a separate region than something else. This is separate, obviously. This is separate. This can't be 5 because of the 5 in the column. Where is the 5 in row 4? It can't be here because of the 5 in the region. Can't be any of these. These are filled out. This can't be 5 because we already have 5 in the light region. This can't be 5 because of the 5 in the column. This can't be 5 because of that 5. And this can't be 5 because of the 5 in the dark region. Therefore, this must be 5, and this has to have 5 digits that are orange. So this can't be orange. This is dark, which forces this to be dark. So this is the region here. This is done. The dark region's done. The orange can go to here or here. This is 5, so this must be either 1, 4, or 2, 3 adding up. 4 cannot be here, so this can't be 1. This can't be 3 either, so this can't be 2. So this is 3 or 4. This is 1 or 2. We know 3 has to be one of these digits here. So where does this dark region get a 3? It can't be from here because one of these has to be a 3. This has to be what? 3, no 4 because one of these is a 4. Or 7, 8, and 9. What is this digit remaining here? It's a 1. So this dark region cannot contain a 1. So this is now 2 and 3. So this can't be 3 here. This can't be 2 because this is 2 and 3 adding up to 5. This dark region can only have 4, 6, 7, 8, and 9 left. This cannot be 5. It's 4, 6, 7, 8, and 9. Okay. This has to have a 1 in this orange region, but it doesn't have a 3. Two, 5, 5, 6, 5, 1, 3, 4. This either goes out that way or that way. This has to be separate region. This could go that way, could go that way, we're not sure. This could be very many digits. 2 has to be one of these digits here. Actually, 2 and 5 have to be those digits. So it's 2, 5 with 4, 6, 7, 8, and 9. Interesting. This can't be 5 because of the 5 in the row. So this can't be 2 or 5. Okay. The red needs a 3 also, but it could go down here. Okay, so this red cannot go all the way over here because it would have to have a 7 there, and we already have a 7. So this has to be a separate region. So we're going to make that yellow here. It could extend here, but we don't know. This yellow doesn't have to necessarily go out this way. The rest of this region is 1, 4, 6, 7, 8, 9. 4 and 7 cannot be here. This can't be 4. This could be 4. This can't be 7. This can't be 4 or 7. So where is the 7? This can't be 7 anymore because of the 7 in the box. This can't be 7 because of the 7 in the column. 5 has to be one of these two. This can't be 5 here. I don't know if this can ever be... Can it ever be 7? We know now. I think this has to be 5? If it's part of yellow, it could be 6, I guess. So that's a possibility. Because we know this red and this yellow region are different. It cannot be part of this red region because that would necessarily have to have 5 cells in the cell for that region. And this would be 5 already here, so that would be 10. So this cannot be red. This is specifically then yellow or blue. If it's yellow, it's at most 6. If it's blue, I don't think it can have 7, right? If it's if it's 7, it would cut off yellow and red, but basically yellow specifically. So this can never be 7. This is 5 or 6, which means this can't be 6. This is 1. So this has to be 1 with 4 or 5 here. Actually, we already knew the 1 had to be here, but... Right, so the reasoning that it can't be blue in 7 is that if it were blue in 7, how do you make this blue region, right? It would have to go something like, I don't know, here, or something like this, or something like this. Either way, the yellow and the red would be blocked off, right? So that's not possible to have this be 7. It has to be 5 or 6. This is 4 or 5. 1 cannot be here. This is 3, 6, 8, 9. 3, 6, 8, and 9 here. This can't be 6 because of the 6 in the column. This light has a 6, 8, and 9 triplet, which eliminates 6, 8, 9 from the rest of that region. So this is 7. That eliminates 7 here and here. Therefore, these can't be 7 either. Whereas this 4, 8, and 9 triplet in this medium gray region eliminates 4, 8, and 9 from the rest of the region. This becomes a 3, 7 pair, which eliminates 3 and 7 in the rest of the row. Where is a 7 in column 1 then? It has to be here. So this is 7, which eliminates 7 here. Therefore, we need a 7 in this dark gray region. Where is a 7 possible? It can only be here. So this is 7, which means this can't be 7 here. This can't be 7 here. This has to be, cannot be 1, cannot be 2 or 3. It could be 4, 5, 6, 8, and 9. No 7. So one of these two is a 5. It's either 4, 1 adding up to 5 or 5, 1 adding up to 6. So this can't be 5. It could be 2, 4, 6, 8, and 9. Okay, so yellow still could be fine here. This could be blue going that way, right? If it's yellow, it has to be 6. That's interesting. So the pink is 1 here and 1 here, or 1 here and 1 here. Yeah, that doesn't preclude the yellow from being 6. 5 cannot be here. Okay. Where is the 5 in the central box? It has to be here. So this is 5. That makes this 6. So this can't be 6. This is a 2-4 pair then, because of the 8-9 pair in the column and the 6 being here. This can't be 6. This can't be 6. This is 5. So 5 has to be one of these 2 digits here. The red needs access to a 5. So the red has to be at least one of these 2. Because it cannot access the 5 here. Can't be here, can't be here, can't be here. So it has to be one of these 2 here. It's 6. Can you have this being blue? I don't think so, right? If this were blue, the problem with this being blue is that you'd have 6 blue cells here, right? And then it would cut off the yellow again, because the red does have to be one of these 2 cells here to get the 5. So this cannot be blue. It has to be yellow. So this yellow must essentially connect 3 here, and the only way it can do that is going this way. So it connects here, and then it has 6 of them here. Can this ever be... Okay, so if this is yellow, this can never be yellow. If it's orange, that doesn't work, right? Because if it's orange, it goes that way, and it would have to be 2 digits specifically. Can't be pink, can't be red, this has to be blue. Since this is blue, this has to be non-blue. This can't be orange because it can't reach. Can't be pink because it can't reach. Can't be red. This has to be yellow then. Okay. So this is all yellow. This has to be all red, because that's the only other region that can reach these. So this is red. That forces this not to be 7 because of the 7 in the region. This is 3. This is 7. We have a 6, 8, 9 triplet in this red region. The red region cannot go here, and it already has a 3. So this has to be pink, because that's the only region that can reach. This can't be pink, then this has to be a different region. It can't be yellow. It has to be... It could be blue or orange. We don't know which, technically. One of these is red. This pink actually has to go this way, because we have 1, 2, 3, 4, 5, 6, 7, 8. We need another one. This is 9. This then has to be red, so this cannot be the 5. This is the 5 because the red needs access to that. So this is all separate regions, all separate regions. This then must be yellow to connect. So that's 1, 2, 3, 4, 5, 6, 7, 8. This is blue. The blue is almost certainly going to be the overwhelming amount here. The yellow cannot go in, so this is a boundary. So this has to be blue here. This is all blue. This is all blue because the orange can only go 2 in here. The pink is all done. So that's done. This has to be at least, this can be only 2. So this is blue. This is at least 7. So it's 7, 8, or 9. This is 7, 8, or 9. Can't be 7. So this is at least 8 or 9. This orange can't go enter this cell without going here. So this must be blue. This is 8 or 9. That means this can never be blue. It has to be orange. One of these is yellow. Blue could go here, orange could go here, and this could be blue or orange. So we don't know that one. These are already separate regions. This is 5. This cannot be 3 because of the 3 in the pink region. Therefore, this is the 3. Yellow has 6, 2, 4. This 6 eliminates 6 here in the yellow region. So where is the 6 in the column 3? It has to be here, which eliminates 6 in the rest of the red region. We already knew that because of that 6. Anyways. This is 4, 6, 8, 9. Actually, this 8, 9, 8, 9 pair eliminates 8 and 9 in the rest of the box. So this is a 4, 6 pair, which eliminates 4 and 6 in the rest of the column and the region. So this can't be 4 or 6. This is an 8, 9 pair, which eliminates 8 and 9 in the rest of column 4. So this can't be 8 or 9. This is 4. That leaves this as a 3. We have an 8, 9, 8, 9 pair here. That leaves this as a 1, 7 pair. Okay. This cannot be 5 or 6. This can't be, oh, we already have, that can't be 6. So 5, where is the 5 in column 9? Again, it can't be in the dark region. It can't be either of these because of the 5's in the rows. So this must be a 5 here. Where's the 2 in column 9? It has to be in row 8 or 9 because it can't be in the dark region because we already have a 2 there. So it's one of the 2's in row 8 or 9. Where's the 2 in column 5? It's in rows 8 or 9. That eliminates 2 from the rest of rows 8 or 9. So this can't be 2. This is 1, which makes that 2. This 1 eliminates 1 here, so that's 7, which makes that a 1. This yellow cannot have another 7, so this cannot be yellow. This has to be blue because orange cannot extend any further. Therefore, this must be yellow here. Therefore, this must be 8, which makes that 8 because this cannot be blue because we already have 9 blue cells. So these are the regions. That means none of these are 8. This 8 eliminates 8 here, so this is 9, which makes this 8, which makes that 9, which makes that 8. This 8 eliminates 8 here, so that's 9, which eliminates 9 here, so this has to be 9 here, because this can't be 9. This can't be 8, and this can't be 8, so it's a 6, 9 pair in box 6, which eliminates 6 and 9 in the rest of the box. This is a 1, 4, 8 triplet. This can't be 8 because of the 8 in the column, so this is 4. This can't be 4 or 8, so this is 1. This makes that an 8. This 8 eliminates 8 here, so it's 6 and 8. This 6 eliminates 6 here, it's 4 and 6. This 8 here eliminates 8 here, so that's 9, 8, 9. These can't be 9 anymore. The 4 and the 8 in the orange region eliminate 4 and 8 here, so this is 6. That eliminates 6 here, so this is 9, which makes that a 6. None of these can be 6 then. This can't be 8 because of the 8 in the column. We are missing a 7 in the orange region. Oh, we're missing a border too. We're missing borders. Oops. So these are the rest of the borders. This is a 7. That makes this 3, which makes that a 7. That leaves this digit as a 6. This cannot be 9 or 6. This is 2, 4, or 9. We have a 249 triplet, which means we have the remaining digits as 3 and 1. This is 3, this is 1. Um, 4 eliminates 4 here, so this can't be 4. This is 9, which means this can't be 9 or 2, so this is 4, which makes this 2. This 2 eliminates 2 here, it's 4, which makes that 2, which makes that 9. This 6 eliminates 6 here, so that's 8 and 6. 8 eliminates 8 here, so that's 4, and this is 8. And that's how you solve it. Yeah, I don't know. I would consider this more challenging level difficulty. Every chaos construction rule set is always pretty much minimal challenging. But this didn't require that much hard logic to figure out. So I would consider this challenging difficulty level instead of hard. But that's just me. I have done a decent amount of chaos construction puzzles, so maybe that's why it's easier for me. But anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.